Okay, so in this example, it says the Fresno Bee claims that the average college student in town consumes 91 liters of alcohol per year. A researcher decides to test this claim and surveys 15 randomly selected college students and finds that they average 97.2, that's even more than 91, liters of alcohol consumed per year with a standard deviation of 23 liters. What can be concluded at the alpha 0.01 level of significance? So on the surface, it looks like yeah, I mean the Fresno Bee said average college student, at Fresno State or whatever, consumes 21 liters of alcohol. A researcher tested, grabbed 15 randomly selected college students and found they consumed they averaged 97.2, which is even more than 91. Now, so maybe it's true, but maybe, of course, maybe that was a lucky sample. I mean, it's only 15 college students. Maybe it's lucky and really the average is 91. And so we'll see. All right. So how to do this test? Let's go to the notes. So here I'm on the Unit 3 notes, page 2. First thing we have to figure out is this a percentage question or a mean average question? Well, it's mean average, right? As you come back here, see it says um, average 97.2. Um, average college student consumes 91. It's average. It's an average question. So we choose t-test for population mean. Mean is average. See down here, it says when you have an average question, you do t-test for population mean. There we go. All right, so we got that. So we choose t-test for population mean. Now, HO and H1, what's up with those? Well, HO is called the null hypothesis. Null means zero, like your check is null and void means zero. So HO, the null hypothesis, zero hypothesis. And down here is H1. So what do we do for those? Well, it says in the notes, again, I'm on the Unit 3 notes, HO is always equal. See that? And is it going to be P or mu? Not P, not percentage. That U is a mu, really. It's a Greek M for mean, average. So HO is always equal. So we come up to HO and we go, okay. So that's going to be mu equal. So this is again always equal. And so what is this? Well, let's come down to the next one. Now the other one is going to be H1. And what does it say about that? H1 is again P or mu. We're gonna go with mu because it's average, is greater, less, or not equal. Greater, less, or not equal. So let's go do that. So that's going to be mu. Whoops. Sure what that was about. Is greater, less, or not equal. Now, how do you know which one? Well, basically, if you look in the notes, it says that if it says greater, you do greater. If it says less, you do less. And then if it says same, different, or just never says greater, less, you do not equal. That's going to be yes. It just never says. Let me show you. So we're gonna actually choose not equal. Why? Because it never says in the words greater or less. If you go up to the words, it just never says that. Let's look again. It says the Fresno Bee claims the average student consumes 91. A, re a researcher a researcher decides to test the claim that yeah, they never say greater, they never say less. So that means, it's not equal. And not equal to what? Not equal to 91. And that means this one will be 91 as well. These two numbers are always in hypothesis tests. They're always the same number. Now let's double check that. How did I get that 91? Well, think about what's being said here. The Fresno Bee claims that the average college student consumes 91, and a researcher decides to test that claim, right? To see if it's equal to 91 or not equal to 91, right? Because the Fresno Bee is saying equal to 91, and the researcher is saying maybe it's not equal to 91. How do I know again not equal? They just never said greater or less. So it's either going to be greater, less, or not equal. It's not equal when they just don't say greater or less. So the two attorneys, the HO and the H1 attorneys, are basically saying, the H1 here, the one of the attorneys is saying the average, yeah, what is that mu? Let's be clear. This is the average for the college students, and this is down here, this mu is the average. So it's the average. They're saying the average for the college students is equal to 91 liters of alcohol and per year. And the other one is saying, no, the average is not equal to 91. So who's right? Well, we have to go down to the notes now and go to the calculator. We're on step 3. Now, is this a percentage question? No, it's a mean average question. So is it no data given or data given? This one is not data given. It's no data given. How do I know that? Well, if you go back up here, there's not data. Data would be like, I'll just write no data. Data would be like if they had a big box, well, a lot of boxes and 7, 8, 3, 2, 9, some numbers in them. That would be data. We don't have a list of data. You'll know it when you have a list of data. There's no data here. So we're going to go, oh, okay. So this one then is a hypothesis test for a mean with stats. Hypothesis test for me. That's in the, I'm getting that out of the notes here. Let me show you. So see, it says for mean average, no data given, online calculator hypothesis test for a mean with stats. There we go. Here's what we're going to use. And we need S X bar in mu zero radio button. S X bar in mu zero radio button. So we see, okay. So we need S X bar mu, did I miss one? What is it? S X bar in mu zero radio button. Yeah, in mu zero radio button. Now, come on. In mu zero radio button. Okay. So S, you know what that is. That's the standard deviation right there. 23. X bar, you know that's the mean. The mean is, what does the mean? You might say, well, it's the 91. Well, no, that's what we're testing. The mean is this 97.2. That was the average for the students we surveyed. And by the way, what was the total number of students in our survey? Right there, 15 randomly selected student. Now, what's mu zero? That's always from H0. So we go to H0 and grab that number, 91. Mu zero, those are that, and then the radio button is from H1. You go to H1 and it's going to be the not equal. Not equal. So those last two, the mu zero and the radio button, we always get from H0 and H1. The number from H0 and the symbol from H1. So remember that mu zero, go to H0 and grab that number. And then radio buttons always from H1, not equal. Okay, so there we go. Let's put that into the calculator. 23, 97.2, 15. Let's go to the calculator. So that's not the calculator. Let's go there. Here's our calculators. So we're going to do we have a lot of hypotheses. We're going to do the number 14, hypothesis for a mean with stats. See number 14 there, hypothesis test for a mean with stats, with statistics. So number 14, go there and S, and I've already forgotten everything. Let's go back. S is 23, 97.2, 15. 23, 97.2, 15. 23, 97.2, 15 for in. Mu zero was, I forgot. Mu zero right there. 91 not equal. 91 not equal. So 91. And then the radio button, I got to choose the not equal. See, I'm going over here with the radio buttons, choosing the not equal one. There we go. So put the numbers in, got them all in there, calculate. There's our T and our P. T is 1.04, P is 0.314. Yep, those are right. 1.04, 3.314. So that's how we got that. So I went to the online calculator, hypothesis for mean with stats, put this information in, hit calculate, get our T value, which we don't really care much about, but our P value we care a lot about. So what do we do with the P value? And we come on down here and we say, all right, the P value, which right here, so the P value is 0.3142. And how does that compare to the alpha level? What is the alpha? Right here, alpha 0.01. So we go, okay, alpha's 0.01. Okay, what kind of symbol? Which one's greater? Well, obviously 31 is way greater than 01. So our p-value is greater right there. And so that tells us everything. That which way this symbol goes, this way or that way, tells us everything. So that p-value is 31. So what does that mean? When p-value is greater, so if p-value is less, well, that's not us. P-value is greater, that's right. When the p is not low, the null must not go. It means when the p-value is not low, it's greater, the null must not go away. That is, fail to reject the null, keep the null, weak evidence. Yeah. So let me go back up and do all that for you. So basically what this means is there's this saying we have, which is a really important saying, that every stat student uses for hypothesis test conclusions. When the P is low, the null, which is HO, right? So the 0 must go. So it rhymes, right? When the P is low, the null must go. Now, is our P value low? Was it low? No, it was not. This p-value here is greater, so it's not low, it's greater, right? The p-value is 31, it's greater than 0.1. So when the p-value is not low, the null must not go. Go where? Go away. So you have to add the nots. That makes sense? Not, not. So when the p-value is not low, because ours is not low, our p-value is greater, the null, the HO, must not go away. So the HO, so we're failing to reject the null. It's not going away. Fail to reject HO because HO must not go away. You're going to keep HO, right? We're failing to, so that's where we get fail to reject the null. And so I'm coming down here. So again, it's all, you can read it all just right here, right? When the p-value is not low, when it's greater, ours was greater, 31 was greater than 0.1, right? 31% for the p-value. The null must not go away. That is, fail to reject the null. Keep the null, weak evidence. So keep the null, as I said, comma, weak evidence. So we got weak evidence. Evidence is weak. And now how do you do, what's the final conclusion? So our conclusion is that the average amount of alcohol consumed by college students is what? Well, it says equal there, equal to 91. How did we come up with that? Well, because we're keeping HO. So remember, in the end, you're either believing the HO attorney or the H1 attorney. They're saying different things. HO is saying the average is equal to 91. H1 has been saying all along the average is not equal to 91. Who do we believe? We keep HO. Keep HO. So we come back here and go, oh, okay. I'm keeping this guy, the HO. What is the HO attorney saying? Mu is equal to 91. The average is equal to 91. So in the end, we concluded that the average, that the Fresno B is right, and that the average amount of alcohol consumed for college students is equal to 91. Well, why do we think that? We did our little study of 15 students and we got 97.2. Yeah, but we think that was just a lucky sample. Why? Why do we think that? What is the probability of luck in this case? Right? You can always be lucky. What's the probability of getting a lucky sample? Well, that is the p-value. That's what the p-value is. P stands for probability. It's probably like 7. What is it? Well, it's right there. The p-value came out to be 0.3142. Notice there's a 31% chance we just got a lucky sample. And you might think, well, that's not that much. Well, that's actually a very high p-value. Notice if for us to believe the results of a study, we need strong evidence, which means a really low chance, lower than 5%. In this case, we wanted lower than 1% chance that the results are just lucky. Well, that is way too, 31% is way too high. We think there's a good chance that the fact that we got different than 91 is just because of luckiness. There's a 31% chance you're going to get those results by just luck. So we say, yeah, that's weak evidence, right? There's a big chance that the fact that you did a sample and got a different amount of alcohol than the Fresno B claim, got 97 instead of 91, that could just be luck. There's a 31% chance that's just luck. So we say that's weak evidence. We don't believe it. We stick with the original assumption. We think, no, it's just equal to 91. The average is probably equal to it. There's not strong evidence that it's different than 91. And so that's our conclusion.